Sequential circuits. In digital system, the logical circuits are classified into combinational logical circuits and sequential logical circuits. In this presentation, we are going to see what are sequential circuits and some of the examples of sequential circuits. The definition, that is, what is a sequential circuit? A sequential circuit is a logical circuit where the output depends on the present value of the input signal as well as the sequence of past inputs. That is the past history of inputs. The past history is provided by the feedback from the output back to the input. A sequential circuit is a combination of combinational circuit and a storage element. The sequential circuits are current input variables and previous input variables which are stored and provides the data to the circuit on the next clock cycle. This is a simple block diagram of a sequential circuit. Here we have a combinational logic circuit and the output of the circuit is fed back to the combinational logic circuit through a memory device, and the memory device is enabled by a clock input. There are two types of sequential circuits. They are synchronous circuits and asynchronous circuits. In synchronous sequential circuits, the state of device changes at discrete times in response to a clock signal. Asynchronous circuits do not need a separate clock signal. The state of the device changes in response to changing inputs. Synchronous circuits. In synchronous circuits, the inputs are pulses with certain restrictions on pulse width and propagation delay. Thus, synchronous circuits can be divided into clocked and unclocked or pulsed sequential circuits. So, this is a simple block diagram of the clocked synchronous circuit. A clocked sequential circuits have flip-flops or gated latches for its memory elements. There is a periodic clock connected to the clock inputs of all the memory elements of the circuit to synchronize all the internal changes of the state. Hence, the operation of the circuit is controlled and synchronized by periodic pulse of the clock. Unclocked sequential circuit. In an unclocked sequential circuit, requires two consecutive transitions between 0 and 1 to alternate the state of the circuit. An unclocked mode circuit is designed to respond to pulses of certain durations which do not affect the circuit's behavior. And this is a block diagram of the unclocked sequential circuit. Asynchronous sequential circuits. They do not have a clock signal to synchronize its internal changes of the state. Hence, a state change occurs in the direct response to changes that occur in primary input lines. An asynchronous circuit does not require the precise timing control from flip-flops. It is controlled by the previous state. The previous state is controlled by the present state. And flip-flops are the basic building block of sequential logic circuits. Flip-flop is a bistable logic element with one or more inputs and two outputs. The outputs are complement of each other. A flip-flop can store 1-bit binary data, either 0 or 1. Flip-flops are used in counters, shift registers and memory devices. There are different types of flip-flops. They are SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. First we will see SR flip-flop. It is basically SR latch using NAND gates with an additional enable input. It is also called as level triggered SR flip-flops. For this is also known as set and reset flip-flop. For this circuit, in output will take place if and only if the enable input E is made active. In short, this circuit will operate as an SR latch, that is E is equal to 1, but there is no change in the output if E is equal to 0. So this is a simple block diagram, and this is a logical circuit of the SR flip-flop, and this is truth table. When S input is given, the output is 1. When the reset input is given, the output will be reset or 0, and the combination 1 1 is known as invalid in SR flip-flop because it is a forbidden state, because it is an unstable state. So this is a disadvantage of SR flip-flop. To overcome this, a flip-flop called master-slave flip-flop is used. This is same as SR flip-flop, but here the condition 1 1 is valid. In master-slave, a JK flip-flop is a cascade of 2 SR flip-flops with feedback from the output of second to input of first. Master is a positive level triggered, but due to the presence of the inverter in the clock line, the slave will respond to the negative level. Hence, when the clock is 1, the master is active and the slave is inactive, whereas when clock is 0 and the slave is active, the master is inactive. This is a circuit diagram, logical circuit diagram of a JK flip-flop, and here's a truth table. Whenever K input is active, the output is reset, and when J is 1, the output is set, and when both J and K are 1, this condition is known as toggle, that is, the output toggles due to this input condition. And next one is a delay flip-flop, also known as D flip-flop. It's the simplest gated SR latch with a NAND inverter connected between S and R inputs. It has only one input. The input data is appearing at the output after some time. Due to this time delay between input and output, it is also known as delay flip-flop. S and R will be complements of each other due to NAND inverter. Hence, S is equal to R is equal to 0, or S is equal to R is equal to 1. This input condition will never appear. This problem is avoided by SR is equal to 0 0 and SR is equal to 1 condition. So this is the circuit diagram and block diagram of the D flip-flop, and this is a truth table. In the truth table, when D is 0, the output will be 0, and when it is 1, the output will be 1. Next one is toggle flip-flop or T flip-flop. It is basically a JK flip-flop where the J and K terminals are permanently connected together. It has only one input denoted by T, and the truth table tells that whenever the input is 1, the output toggles, and when the input is 0, there is no change in the output. This is known as toggle flip-flop. So these are the different types of flip-flops, and the flip-flops can be used to design registers. That is, a group of flip-flop is known as a register, which is used to store n-bit binary number. The n-bit register will consist of n number of flip-flops, and it is capable of storing n-bit word. The registers that allow such data transfers are called shift registers. There are 4 modes of operations of a shift register: serial input, serial output known as SISO, SIPO, PISO, PI and PO. So these are some applications of flip-flops, registers and shift registers. So these are known as sequential circuits. Thank you.